Hello viewers, the shear strength of the soil is the resistance to deformation of soil particles upon the action of a shear stress. When soil is loaded, shearing stresses are induced in it. When shearing stresses reach a limiting value, shear deformation takes place, leading to the failure of the soil mass. The failure may be in the form of sinking of a footing or movement of wedge of soil behind a retaining wall, forcing it to move out, or slide in an earth embankment. The shearing resistance can be determined in the laboratory by four methods: direct shear test, triaxial shear test, unconfined compression test, and vane shear test. Depending upon drainage conditions, three types of shear test have been developed: unconsolidated undrained condition, consolidated undrained condition, and consolidated drained condition. In this program, we shall demonstrate the direct shear test as per IS code 2720 part 13. To conduct this test, we need the direct shear apparatus that consists of shear box. It is horizontally divided into two parts, having connecting pins, spacing screws, base plate with cross grooves on its top face, loading pad with a steel ball on its top, two pairs of grid plates, one plain and other perforated, porous stones, one pair, metal plates, one pair, container for shear box. Loading system to distribute the load from the yoke over the specimen normal to the shear plane. Set of weights for normal load. Proving ring with dial gauge accurate 2.01 mm to measure the shear force. Knob for fixing the proving ring. Switch. Electric motor. Hand wheel, rollers, locking pin, clutch and gear for different rate of loading for different soil. Micrometer dial gauge is 2 number to measure vertical displacement. Dial gauge to measure horizontal displacement during shear. Sample trimmer, sampler, rammer, stopwatch, soil specimen and water content determination apparatus. In this program, we shall determine the shear strength parameters of the soil under unconsolidated, undrained condition. First of all, take a specimen of soil to be tested from undisturbed sample. Assemble the two halves of the shear box using connecting pins. Place the base plate inside the box. Now place metal plate instead of perforated stone, as this test is for undrained condition. Place one grid plate without perforations over the metal plate such that the grids are perpendicular to the direction of shear. Carefully place the soil specimen inside the box so that it rests on the grid plate. Over the top of the soil sample, now place another grid plate without perforations such that the grids are perpendicular to the direction of shear. Slightly press this grid plate evenly so that the grids are buried into the sample. Now place another metal plate over this grid plate. Place the loading pad on the top of the metal plate. Place the adjusting pins in the box. Now place the shear box inside the shear container. Bring the proving ring assembly in contact with U-arm provided with top half of the shear box. Slight movement of the pointer in the dial gauge is an indication that contact is established. Place the dial gauge for measurement of horizontal displacement. Fix the dial gauge on the loading yoke to measure the vertical displacement. Set all dial gauges to 0. Place a steel ball on the spherical groove provided on the loading pad. Seat the loading yoke on this ball. Raise the upper half of the shear box through 1 mm by operating the adjustment screws. Remove the pins connecting the upper and lower halves of the shear box. Now apply the required normal load on the hanger of the loading lever. For the present case, it is 0.5 kg per centimeter square. Set the clutch and the gear for applying shear displacement of 1.25 mm per minute to the sample. Switch on the machine and the stopwatch simultaneously. Record the readings on the two displacement dial gauges and the proving ring dial gauge at regular interval of time. Continue applying the shear force till the specimen fails, which is indicated by a kickback of the pointer in the proving ring dial gauge. If such a failure does not occur, continue shearing till the specimen undergoes a shearing displacement of 12 mm. Here you see the sheared soil specimen which was under test. Conduct at least 3 tests on separate specimen having the same density and moisture content but applying different normal loads. Here you see a standard proforma for direct shear test for recording the values of various parameters during conduct of test. Record all the observations in the proforma. For a normal stress of 0.5 kg per centimeter square, the shear stress at failure is 0.37 kg per centimeter square. Shear stress is equal to shear force divided by area of specimen. At a normal stress of 1 kg per centimeter square, the shear stress at failure is 0.55 kg per centimeter square, and for normal stress of 1.5 kg per centimeter square, The shear stress at failure is 0.77 kg per centimeter square for the present soil. Draw a graph by plotting normal stress as the abscissa and the shearing stress as the ordinates corresponding to failure states. Join the points corresponding to the state of failure by a line. This line gives the Mohr envelope for the soil. Measure the intercept which this line makes with the shearing stress axis. This gives the cohesion C. Measure the angle which the line makes with the horizontal axis. This gives the angle of shearing resistance. For present test, C is equal to 0.14 kg per centimeter square and phi is equal to 23 degree. The value of C and phi will vary with different state of soil.